Let me do this. Guys, if I find that your mic is on, I'm gonna have to remove you out of the session, right? And if I remove you, you won't be able to enter again. So I'm gonna call this. I'm just gonna label it as ICG, right? The intermediate code generator. So what we know about this one is that this is some sort of like a phase or a stage, right? We can label the intermediate code generator as a phase or a stage in the process. You know the process. This is I can call this process compiler design, right? We know that what we're doing, whatever you're doing here, it's based on the compiler design. So we know that the intermediate code generator is some sort of a phase or a process of compiling. So here, what we're doing, remember I said that we are translating this code to some sort of a language that the computer will be able to understand, right? So here we're compiling a program. We are going to be compiling a program. So now what happens when we are compiling a program using this phase? What happens is that the compiler, so let me see where the compiler, what happens with the compiler is that it is going to translate, so which is what we're going to be doing. We'll translate our source code to tag. First we'll translate it to DAG, tag, and then you know what types of formats we have from tag, right? You know that we can take this to I think it's the first one is quad, the second one which you'll confirm with me, right? The second one is the tropos, and then we also have the indirect tropos. I don't know if you guys have done the indirect tropos, but yeah, we have these three types of formats. So now, as I'm saying that this is the part where the compiler is going to the compiler, where the compiler translates the source code. Yeah, this compiler is going to translate the source code. It's going to translate the source code into an intermediate. Then what are those intermediate representations? So intermediate representations, we are talking about the ones which are mentioned, DAG, tag, and so on, right? So this is just a process that is, let me say, this process won't necessarily be whatever the tag, DAG, won't necessarily be the machine code, right? But it is way simpler than the high level code, or than the code that we give to the computer. So the computer can easily understand this code than the one that we give it, right? So now I think we can look at DAG. So the first thing that I want us to look at, as I said, I want us to look at DAG. So when we look at DAG, let me just call this constructing DAG. Right, I'm sure we all know what is DAG, what is meant by DAG. If you don't know what is meant by DAG, it means that you should consult with your notes. So first, what happens to DAG is that what happens that we give, let's say we have an expression AB. You see right there. So how you gonna draw? You realize that some books, when they draw this, they first put this, they put a plus, then they put the operands. You see right? You have an operand and operand. So this is an operand, and these are operands. You see right? So, but what happens with us is that we are not going to put this. Second, we're just going to put a sign. So the first DAG that I'm going to draw is this one. So this is our DAG. You see right now. This is the first DAG. So this is a simpler DAG. And then the second one, let's assume now that I'm given A plus B plus C. And they say I should draw this DAG. You see right? So what's gonna happen is this. What you do, you remember with BODMAS, but in this case we're not gonna use BODMAS. We're gonna use what we call think it's PEMDAS. Yeah. So we're gonna use what we call, I'm sure Sir has mentioned something like this, right? He did mention what is this, and also how do you apply it. So what happens is that this, I'm gonna try to describe this. This stands for parenthesis, which we know what is a parenthesis, right? These are brackets. These are brackets. And then this stands for the exponents, which here we can talk about if I have x2. You see, right? Then here for m, we talk about multiplication, which this one we're talking about this star. Then this d, we're talking about division. These ones you know them, right? Division, addition. These ones you know them. And subtraction. So what we have learned from high school is that it's either from high school or primary, we've learned that these two have the same capacity or the same order. These are of the same order. That is what we have learned, right? These are of the same order. Then we have learned also that these are of the same order, but these two are not of the same order. So I can now describe their orders. This has a higher order. This is the second highest order, the third highest order, and this is the fourth highest order. We see right now. So that is how we would describe PEMDAS. So what happens here is that if you come across an expression like this that we're given, and you want to draw or you want to construct a deck, what you're going to do here, you are simply going to consider the lowest order. You see right now, you are simply going to consider the lowest order. So what you're going to do, you're going to say that I'm going to start with this, the lowest order. I say plus, I put my C this side, then I come to the second lowest order, which in this case it's only this. I have B, A. You see right now, you consider the lowest order first. Now for that matter, let's go to the third one. If you have a question, don't be afraid to stop me. If you type there on the chat box, I can't see it, so make sure that you open your mic and say something. So now the second one that we can have is this one, A plus B star A plus B plus C. We see right now, when we come to draw deck for this, we realize that we have parentheses. It means that this, whatever that is inside those parentheses, is considered to be the highest order. You see right now. Now we come to the second highest order would be multiplication, and the only things that we have here is parentheses and multiplication. So it means that we're going to be forced to start with star. Now after starting with star, we can decide if we want to go to the left one or the right one. If I go to the left one, it means that I'm going this side. And if I go inside now, let's say I go inside here, I'm going to consider the lowest. You see right now. So this will be the lowest order. You see right, which is plus. So I'm going to have my plus here. I know here I have C, and below that plus, I have B. You see right now. And I know that from this side, remember here, I have something. I have to consider this. I have A plus B both sides. So let me look at the left side first, and then I can see how I can connect the two. This is some sort of like, most of the times they can bring you such an expression where it's a bit difficult for you to draw the deck. But what you need to do is you just need to draw whatever you see that is not matching with the other ones. Then whatever that is matching, draw it at the end, or start with it, then you finish, right? But I prefer drawing it at the end. Now I come this side. I know that this side I'm going to have plus. Here it's only one. Then at the end I have A. Here I will have B, and I know that B is already there, you see, so I'm just going to connect it to B. You see right now. And I realize that there's something else that I'll need from this expression. I'll have A plus B plus A. So it means that I can just take this, connect it there. So if I wanted this expression to be A plus B plus C. So like this, I'm pointing here, I forgot that you can't see it. So it's A plus B plus C. You see, if I want this, I can just easily move like this. You see right now? And if I wanted this one, I can just easily move like this. And if I wanted this, I can easily move like A, B, C, like that. You see, A plus B plus C, just like that. If you have a question, don't forget to ask, right? So let me erase this. Yeah. So this would be the DAG for that expression. So this will just be a DAG for that expression. Yeah. So any question? If you have a question, you can just ask. So DAG is very important, guys. It's to be a bit tricky for you not to draw DAG. So now I have this expression. I think this one, I don't know which one is coming from your guide, but I took some recently from your guide. So now we have this, which is A plus A. And then we have it's star B minus C plus B minus C. I think this one is coming from your guide. This one is star. So now when we look at this, right, we're gonna write our PEMDAS here. You know, this is 1, 2, 3, 4. Okay, let me just write like this. I'll just write whatever that is there, right? So yeah, this is 1, 2, 3, 4. Then I do this. I have the highest thing that I have here. It's brackets, which is parentheses, right? So I have this, the highest, which is 1. Then the second highest, I don't have exponents, so I have multiplication. This is the second highest. So 1, and this I'll just call it 2, 1, 2. The third highest, I would have addition. I'm looking at the outside now. I don't look the inside. Whatever that is inside is counted within this parenthesis. You see, right? So for me to draw this diagram, right? Now it means that, okay, let me go back here and explain something here. I think I need to explain something. Even though here plus and plus have the same precedence, right? The one that comes first will have the higher precedence than the one that comes after. Because when the compiler comes, right, it's going to scan these character by character. You see, right? You see, it's gonna scan them like that. It takes the tokens. And then when it does that, the one that comes first, it's the one which will be computed first. You see, right? So it means that it has a higher precedence than this one. So that's why I started with this one, do that one, then I come back here, do that one, then I correct my A, B, and the C there. You see, right now? So this is the case also on this one. Now, let me see on this one if, okay, this one was inside brackets. When we come here, we realize that plus here is the least one. You see right now? So we're going to take this one plus has higher precedence than this one. So we're going to start with this one. You see right now? So we start with that plus. When I start with that plus, I realize that on the right, I have a multiplication. So I can have multiplication here. And that multiplication is connected to what? To D. You see right now? And this plus, from this plus now, I'm going to the one with a less precedence. I'm still dealing with the ones that have less precedence this side because I have them on the left. The reason why I wrote multiplication is because this is the only less precedence this side because the brackets are higher than the multiplication. That's why I was able to put the multiplication. You see right now? And then this side I'm going to have the plus. And this plus is connected to what here? To A. And after this plus, I have what? I have multiplication. So this will be connected to a multiplication. You see right now? And I realize that there's a between plus and multiplication. So it means that this a is connected to multiplication and that plus. You see right now I'm getting rid of all the difficult things that I see here. You see, all the outside we're done with. Then we realize that this is after this multiplication, this minus. And this one is before that multiplication. Before this one. You see right? And that minus is connected to B and C. Maybe you can go check that DAG on your slides. You realize that the DAG is like this. You see right? So I can just share this there in the group. So we see that it's like this. So now when we come to, if there's no question, it means that I can proceed, right? Because I think I've completed this DAG. So this will be the DAG for that expression. So it will be much simpler for a computer to understand this one than to understand. It will be simple for you to understand the DAG than to understand this expression. You see right now. So now we can go to the 3 address code. If we don't have any questions to compute, we can go to the 3 address code. So now, okay, so now we come to the 3 address code, which is called tag. After DAG we come to tag. So I'm sure this one, yeah, that one I just called it constructing DAG. Now we're going to 3 address code. So now when we come to the 3 address code, is that now we need to understand what is happening here. Oh, what is this representing? We see right. So what happens here when you come to the 3 address code is that or maybe how I can define it, right? I can say that this is a part of the intermediate representation. You see right now, which which the compiler is going to utilize, and also it makes things simple, or it makes things easy for the process of the code generation. Remember, after here we're gonna have code optimization, then we have code generation. You realize that when you come to code generation, most of the things that we're gonna be doing, they'll be more based on the tag. You see, maybe where you're given something like A is equals to A I. Usually this, you'll see it when you come next semester, usually. Not let me say D. When you come to next semester, assembly language, the language which is closer to the compute, which is called a low-level language, right? That you'll be using such things. So this part of the code generation is just that I'm sure in class you can realize that the end, they don't touch it a lot, but then it will be there in an exam. So also next semester you'll find that there's a lot of it there. So what happens here is that sometimes we're given complex expressions, right? And what we need to do is to do what is to decompose them into simple steps. So that's why you'll see when we come to 3 address code, we're gonna be talking about things like, or we're mentioning things like T1, T2, T3, which we equal some operation, some argument, operation, argument, or sometimes some argument, yeah, something like this. Or we talk about operation, argument, or some unary assignment, which is like negative, right? Those are the unary assignments. So you'll see such things when you come to tag, the 3 address code. So when you come to the 3 address code, we're gonna be talking about the Also, after having the 3 address code, the intermediate representation, we'll look at the types of these formats that can be represented in, which also is the quadruple, the triple, which I've mentioned, and also the indirect triple, right? So, yeah, let me just, I think this one, I don't need to define the 3 address code, right? So we can just jump straight to time, and then we'll look at some expressions that we can discuss. So first, let's say they say convert. Now they say we should convert, or yeah, let's say we should convert. So we convert the expression, this expression, which is a star minus b plus c, is right into 3 address code, which is also called tag. So don't be shocked when they say convert this to 3 address code or to tag. And then what we have first is a, we're going to have a star. Oh yeah, I wanted to write, let me write this. Yeah, so what we have here, we have a star minus b plus c. You see, right? So let me give you a tip here, right? So there are 2 ways or 3 ways you can apply a 3 address code. You can start here, you go that side, you can assign this. It's possible, it's very much possible, right? You can start and say T1 is equal to A, you come and say T2 is equal to you come here and say B, you say T3 is equal to T2 plus C, you come and say T4 is equal to minus T3, and then you come and say T5 is equal to T1 times T4, which is very much possible. You see right now. But there's what we call code optimization, which is the next step, right? We need to optimize our code. In other words, we need to reduce the number of steps. Remember, the best way you can make your code to outstand, it's if it is faster, it takes less space. That's why we have all these code optimization, compiler design, all these theories. It's for us to work on that. So what I can tell you, right, the best way to compute this, even though that one is correct, the best way to compute this is if you see that the brackets start with the one that is inside the brackets. You see, right? Or even if that one you had done this, let me show you here. Someone would have said, okay, man, let me just and say plus C. You erase this step. You'll also be correct. You say, right, you say T3 is equal to, or let me just change this to T3, 4. And then this will be, no, this one will be 2. In other words, I'm saying that if I take this, right, I multiply by negative, I get this. Then I take that T, this one is T1, right? T1 times T3. It means that I'll have steps up until T4. You see right now. Still, this is not the best practice. You see? Still, it's not the best practice. So, or someone would say that, which is what I want us to do. Someone would say this. Someone would come and say, since I have brackets, check this. You have brackets. Every time you have brackets, I want you to do this. Every time you have brackets, You see, right? Every time you have brackets, you start with the one that is inside the brackets, always. So we're going to say that T1 is equals to B plus C. You see, right? And we know that T1 has a negative. So I'm going to say negative T1, which is this. That is a unary assignment. This is unary assignment. You see, right? So I'm assigning a negative to that T1 expression, B plus C. Then T3, I come and say A star T2. I'm done. You see, we know that T2 is equal to this. So I'm saying A times that. You see now, the lowest that we could reduce that term was up until T4. Now, just because we used this rule to say that if there are brackets, we're going to start with what's inside the brackets. You remember BODMAS, right? So we know that when we are using this one, when we are using DEG, we use PEMDAS, but we always start with the lowest precedence, the one of the lowest order. Then if we come to tree address code, I'm going to focus on what's inside the bracket. I start with it. So in other words, I'm starting with the highest precedence. You see, right now? So, and I move with it. So now if I come to B, I'm given that I have A is equal. Sometimes they have equal sign, right? Sometimes they don't. So the first one which we had, they didn't have an equal sign. So, but if it had an equal sign, let's say that was equal to D. I was going to say D is equal to T3. I assign all these results to D. You see, right? So since that one doesn't have an equal sign, we leave it out. So now we have this A is equal to star minus C plus D. We see, right? And then now what we're gonna have to do now, we are going to find a tree address code for this problem. So this will be let me plug charger for this. So this is going to be, I'm going to start with T1. I start with what's inside the bracket. What's inside the bracket? Minus C. You see, right? And then I can go anywhere. I can go left or right. But remember I said this. I said that you start with the lowest precedence, with the highest precedence here. So it means that I must go to left. You see, right? So this will be T2 is equal to, remember this one has, if I use PEMDAS here, I'm using PEMDAS for all. This one has the highest precedence. That's why I started with brackets. The second highest precedence which I see here is multiplication. Now I'm going to multiplication. You see, right? That means that now I'm going to have let's say maybe I plugged minus C, right? This would be T1. We know our minus is T1 times B. So that's why when you check your guide, you realize that instead of writing B times T1, they wrote T1 times B. Just because of how you moved, right? But even if you would write B times T1, you'll still be correct. And then now we're gonna have now T3. Now we are left with this one, so we're just gonna add, we're gonna say T2 plus D. Now we're moving that side, and this is our T2. You see, right? And then we add D. T2 plus D. So this is all stored at A. So I'm gonna say A is equal to T3. Now this would be our tree address code. Now sometimes, guys, they can give you a code. They say write the following code in tree address code. You say, right? Maybe they give you a code like this. Maybe they say that they say that write the following maybe they say write let me not make it long. Let's say write tag, for the following code. Then they give you the code, and they say that the code is like for I equals 1. Then they say I less or equals to 10, they say I plus plus, then they come and say A I is equals to X star 5, then they say close. So now if we're given this and they say that we should write a 3 address code for this, first you're going to start, you see when the compiler comes, like you're going to read it like how the compiler is going to read it. The compiler will start and say this. The compiler will say that first I check I. So first we're going to check I is equals to 1. You see, right? Just that you'll see this when you come to, just as it's based more on second semester, just they can bring it, right? As long as it's there, they can bring it. And they might not show you this type of a question. So we have those have been those have done this coding thing with, you know that what happens here when how you compute for loop. So this is a loop, right? You start by checking I equals 1. After checking I is equals 1, you come inside. You fill your 1. You say that means that we need to initiate a loop. We'll call it loop L1. We'll put those like this. We'll put this. Sometimes you can have 2 of them. You have 1. You'll learn more about that for next semester, right? So you must pay attention to, plus you don't have practicals next semester. So whatever you do, you're on your own. So you're going to learn that on your own. So we print that, right? What we do, it reads L1, comes inside plug 1 here. It doesn't compute anything, just plugs 1. And then it goes back to say, is I, which is 1, less than or equals to 10? And the opposite of less or equals to 10 is what is greater than 10. So you can either say if X, not if X, if I, we're dealing with I there. You can also write the opposite here, it's less than 10. We are going to L2. If this is correct, right? If this is correct, so this will be called our L1, the first computation. And then if this is correct, we'll go to L2. You said, right, this is L1. Whatever that will be happening inside this execution is here. Let's just name this one. Since it's going to come inside, then the outside will name it L2. So if this is greater, right? If this fails, in other words, I'm saying that if this fails, this will go here. So this will be L2. So this will go to L2. So I'll write L2 there. But first I need to write what happens, go L1. Right? If that fails, it will go to L2. But if it doesn't fail, it will come inside here. Remember, according to 3 address code, we're going to let that be T1. So that T1 will be equals to X star 5. You see right now? And then after we take our AI, we equate T1. You see, we assign that, we assign T1 to that as there is there. So after having this, the compiler, after computing this, the compiler will go back to increment. So we must increment here. Must have that I will be equals to, incrementing is the same thing as adding 1. Then when that is done, it will go back to L1. Go to L1 and do the same thing. It will go back here to the loop and do the same thing. You see right now? It will go back to the loop and do the same thing. Up until it is done. When it is done, it will go to L2, and L2 must be somewhere here. You see right now? So there is this is the kind of language that the compiler would understand. Just that if such a question they bring it, I know the ones they brought a question based on this. Last, if you can check that it's there, they will always bring a question that they don't want people to get total, right? So they'll bring a question that is out of this scope, just to make sure. And they taught you 3 address code, so you can't go and complain and say you didn't teach us this. I'm sure we agree with each other here. So is there any question? Any question? So if there's no question, it means that we can proceed, right? And do the ones that we are certain that these ones are coming. There's no way. There's certain questions we know. This one is coming. So now we come to the implementation of 3 address code. So the question is, how do we implement 3 address code. Let's say we have implementation of tag. Let's say we have drawn tag. Now you need to implement it. So how you can implement it? You have 3 representations, right? Which I said we can implement it using the quadruple. So don't confuse this, right? This is not a type of a tag. It's just an implementation method. You can implement it. Like, how do you implement it? You can take tag, we implement it using quad. Then from quad, we can generate a triple. Or we can have indirect. Did they teach you guys the indirect triples? Did they teach you guys this one? Did they teach you the indirect triple? If yes, please let's participate. Did they teach you that one? Or maybe let me go to the messages. Maybe I'll see someone typing. No one is typing. Did they teach you the indirect, guys? We don't have time. 4 o'clock, electricity is turning off. Did they teach you the indirect triples?
I think so.
You think so? No. I thought I was, you replied, I was going to end the session. Usually if people are not participating, it means that you don't want to learn, right? So let's be careful. If I ask questions, you don't answer. I ask you like 3 times. If you don't know, just say no. And then if you don't answer, it means that you don't want to learn. And then or maybe you're sleeping. You see, I'm talking to myself. And then minus star. I think this one is star minus C. So now we're given this expression. This is in the form of infix, right? And then what we do here is first we need to translate this to a tag. First, to a tree address code, right? Let's translate this. Here there are no brackets, so I'm just gonna move, you see, with the flow. But not just with the flow, I'm gonna come and say this. So I check which ones I have here. I have multiplication, and I have a negative. This is not and it's on negative, right? So whenever we have a plus, a multiplication and a negative, we start with a negative always. You see that even though it's not inside the brackets, we start with a negative. It's a unary assignment. It is said to have the highest precedence, right? Or equal, or something like that. And then we start with a negative. We're going to say minus C. Doesn't matter whether it's this one or this one. After that one, we come to, it's either go this side or this side. But I realized that the best way to go is this side, because here I have a star. You see right now? So, yeah, let me do this. Then now we come to T2. When we come to T2, we realize that I have this first. I need to multiply what I have, T1. That's why I'm not going to say. Remember last time I explained why we're not going to write this. B times T1. Well, I explained why we're not going to type. Because already, if in your calculator you typed -2, what is there on your calculator is that -2, which is in T1. You see, right? Whatever that will be multiplying, whether it's on the left or right, it will come after. You see, right? And then we have T3. Then when we come to T3, we see that I have plus this one. I think I have, did I copy the right question? Let me see. This is, yeah, it's the right one. It means that I stopped here. So let me see what else we can do. So since we have this, is the same thing as having this. We agree, right? But we have to decide, is this one for this or for this? You see right now? And then after deciding that, let's say it's for the one on the left, then I do the one on the right. Now I have to do the one on the right. Then I have minus C. You see, right? Then all I have 2, 4 will be equals to minus C is here. So I'm going to have it stored on T3. You see right now? and what we have on the right is this. So what happens here, guys, is that I'm going to have my this T3 times B. You see, right? The T3 came first. But remember this, even though we realize that on the calculator, remember I said that when you're doing a 3 address code, you must put the T1 first. But if you're drawing this on a quadruple, it's best to interchange these two, unless if it's not a quadruple, right? It's best to interchange. So we're going to interchange this. The reason being is because when we're going to draw a quadruple, we're going to have to interchange either way. So even if you were to write this, it would still be correct. You see, right? So since the other way, I'm just gonna, so now you'll know why I'm writing this. So I'm going to interchange this and write B star 3. You see, right? So I'm just going to start with this, regardless of what the calculator says, unless if I was drawing a tag only. But since I'm dealing with the quadruple, I'm going to write it like this. So the reason being, I'm writing like this because here B came first, B will come first. B came first, B must come first. So that when I draw a quadruple, everything can be correct. Now I come to say T5. Now I have this and this together, so I can add them. You know, they must be added. The operand in between is plus. You see, right? And this one, the first one comes from T2. So that is T2. The second one comes from T4. You see, right? All this is stored in A. So I'm going to store all this in A. A is also T5. You see, right? Then now I come and draw my quadruple. So here, let me just write this text so you don't confuse things. I'll just write tech here. And then come and write the quadruple. You see, right? And then the quadruple for this tag, or I can just write quadruple. That's fine. And then what must happen here is I must have an operator. I have an argument. I have argument 1, argument 2. I'll explain why I'm having this. Then I have a result. The reason why I'm having this, guys, is because if I look at one expression, like this one, for example, this is the result, is here. The left operand, argument 1, right operand, argument 2, then an operator, which is an operand. It's like that. You see right now. So that's why we're going to have this for quad. If it comes to other books can tell you that here we have hash. You see, which is a nice practice for a quad. But then yours says that quad is not supposed to have hash. Hash is going to be on the triple, where we exclude this and put the quad. But let me just put the hash there. Don't put it in a test. I'm just going to put it just for reference, or maybe I'll put it after. It helps. You'll see it helps when you're doing what. And then I'll show you how easy this is. So first we start with T1. You see, right? T1, the operand is that negative. T2, the operand is times. T3, operand is that negative. T4, operand is times. T5, operand is plus. And then this is, yeah, then it's like that. And then now we know that since we have these operands, we can easily draw or sketch this tag. Do you agree with me here? I think it's for B star minus C plus B minus B. Yeah, which is a nice practice. Do you agree with me here? We can easily draw a tag for this, right? Then we come to T1. We realize that T1, the first argument that we have is C. So I'll have C, and this is stored in T1. You see right now. The second one is stored in T2. So I can easily go around and write this. The third one, T3. This one, T4. This is stored in T5. You see right? And then I come to T2. T2, I have left operand is B. Right operand is T1. Then I come to T3, I have C here. T4, it's B. T3. T5, is it T5? Yeah, T5, it's A. Oh, yeah, the left operand here, I'm not supposed to write T5 yet. Let's write there. The result here is A. Yes, T5. It's an operand T5. So I have this. Do you agree with me here? So this will be our quad. Now we translate this quad to triple. When we translate this quad to triple, we exclude the result, we write hash. Op arg1, arg2. So wherever we see T1, T2, T3, we're going to replace. We replace those. The question is, what are we going to replace with? Let's go write that. I'm just going to include this here. This, I'm just doing it so that you can see, right? So T1 is here. Operand is 0, 1. Okay, let me write it there. Let me write them this side. I think this side. This is 0. I'm just going to write like this then. Yeah, this is 4. Wherever I see T1, I write T0. Yeah, I write 0. Whenever I see T1, I write 0 in brackets. So the hash here, how many we have in here? 1, 2, 3, 4, 5. 5 operands. 1, 2, 3, 4, 5. We have 5 operands. On hash, I'm going to just write 1 up until 5. Right? And then on operands, I have minus times minus times plus. And then on arguments, I have C, B, C, B. I'm not going to write this T5 for now. I'm not going to write it for the time being. And then this one for, let me see, this one T5, right? Oh, this one is not plus, is minus. Let me see here. Yeah, I think I forgot something here. I forgot on T5. I forgot something. On T5 I have plus. The left operand here, it's left operand is T3. I forgot to write T3. This was B, T3. This is T4. Yeah, I see why I can write this one here. And then T4. And then here the last one is equal. And then the left operand is T5. Then the summation, this is stored in T5. And the summation is A. The result is A here. The summation, the result is A. Then on T5 we'll have T4. Yeah. And then 5, because I can see here we don't have an equal sign, right? That's how I was able to see that this is supposed to have an equal sign, and there's something that we must swap at the end. So at the end here, instead of writing here, you see the last one is what? Here I have T3, right? So on T3, instead of writing 3, I'm gonna write 2 in brackets. So you know this is the one which is lesser than 3 is 2. So I'll just write 2 in brackets. And we know here that T3 is equal to 2 in brackets. You see, right? And then I come to the last one. The last one always, which is next to the equal sign. I'm not going to write 4 there in brackets. I know that T5 is equal to 4 in brackets. I'm going to replace that by my result A. You see, right? Then I swap that. It's like I'm swapping these two. This one, it was on result, but I'm not going to put in result. I'm going to take this, put it here. When I come to triple, you only do this to the last one. If there's an equal sign, the one with an equal sign. So I'm going to swap this. Take T5, put it on this position. Take this one, put it on the position of argument 1. You see, right? So now I come back here. This side on argument 2, I have, this one is empty. The second one I have T1, which I'll just put 0 here. I'll just put 0. And then after T1 I skip C, and then T3, just put 2, T4, I'll just put 3. Yeah. Now this will be our triple. for that expression. Any question? So that will be our triple for that equation. So now we come to the next question, right? Then we have done a quadruple, triple, but I won't do the indirect triple one, right? So now we come to this one, which is the second expression that we have here. We have that A will be equal to minus B times D plus C. And then we're going to have plus minus B times D. The highest precedence is what? Is the one that is inside the brackets, which is minus B, which is this. I know here there's a, if you were going to start from the left going to the right, it would still be correct because you're lucky the one which is inside is the one which is minus B, right? Then T2, the one that comes first, the one which has a higher precedence between plus and minus, when we have to choose where we're going, it's the times 1, you see. So I'm just gonna say T1 times D, you see, right? Then I come to T3. T3 will be equal to, now I need to go this side. So now when it comes to T3, I'm taking the one going to the left, you see, right? So it means that on T3, I'm just going to have my T2. This is T2, I add C. So we know that after here, I'm going to C. After C, I'm going to, I can go to D, or instead of going to D, I can decide to have B times this. Then I add the two expressions. You see, right? But the best way after computing this, take this one, then you compute this. So it means that now I'm going to have T3 will be equal to, this will be T2 plus C. And then here, I'm going to have T4 will be equal to, then I look at minus B. T5 will be equal to T4 times D. And then now I know that I have T3 and T5. Then T6 will be equal to T3, is it plus? Yeah, plus T5. Then this is stored at A. Do you agree? Is there any question? So if there's no question, it means that we can draw our quad. We have like something like 4 minutes, just in case electricity turns off fast. We take this to quadruple. So we know we have the op, the arg1, arg2, and the result. Our result is from T1 up until A. So I'm going just to have T1, T2, T3, T4, T5, T6 until A. Then our operators, our operands is first, let me put this so they can align, right? So the first operand is negative, which is on T1, and then times, plus, minus, times, plus, hey, did I miss something? 2, 1, 2, 3, 4, 5, 6, 1, negative, times, plus, oh, yeah, I missed this. Because I couldn't put this equal sign here. Plus, this is minus, times, plus. So I was just checking these operands here, you see, right, and put them there. So this is the best way to write it fast. Then now I can look at the left operands. Left operands, I have B, T1, B, T4, T3, Did I forget something again? Oh, I forgot T2 here. T2B, T4, T3, T6. And then the right operands is T5, D, C, D. I'm done with the quad, right? Then I come to a triple. Then the triple, I'm just going to have my hash, the op, arg1, arg2. So let me start with the hash. I know I have 1, 2, 3, 4, 5, 6, 7 tables. So I'm going to have 1, 2, 3, 4, 5, 6, 7. Then the operators that I have, the operands, it's minus, times, plus, minus, times, plus, equal sign. So I know here that on T6, I'll put A here, and T6 will be covered by 5. Then T5 will be covered by 4, T3 by 2, T4 will be covered by 3, D will remain as it is, B, T2 will be covered by 1, T1 will be covered by 0, D, B. Then that is our triple. Any question? Yeah, I think it's 4. We can stop here. If you don't have any question, yeah, this I took it from your guide, right? You can see that if you go check, this is the last one from your guide. If you go check, you'll realize that it's the same thing. So I want you to write this one. I'm gonna give you this one to write. So the first one that we have, let me see, we have that. So what you're going to do here, you write a tag, you write a quad, row pool, you write a triple, right? So yeah, I think if you can do this, then we'll be fine. So any question? So also if you can also, if you like, you can also write indirect triple, even though I know, but I think we can do it indirect triple. So if you can also write this, you'll be fine. So any question? So with the indirect triple, right, what you do is, let's go back here. Indirect triple, what you're going to do, right, you're just going to have 2 for the indirect triple. What you're going to do for the indirect triple, just going to have hash, then statements. Right, then we know here that for our hash we have 1, 2, 3. So what you're going to do, you're just going to merge the one that are the same, that they look the same. You see right now, you're just going to merge the one that look the same. If they look exactly the same, you're going to merge them. So not really the same though, the one that contains the other one. So I think yeah, I think for this one I'll have to do a proper video for it. So yeah, but if I checked on the guide, they didn't teach you this one, right? But what you do, you're just gonna, it's like using pointers. You point to the table, this one goes with this and this goes with this. Like for an example here, you see that 1 and 3, 1 and, is it 1 and 3? 1 and 4, they are the same. You see, right? 1 and 4 are the same. So we're going to point to the same thing. So we'll look at those and try to inspect, and then we focus on it. So I think we can stop here.